Welcome. This is the visual abstract for the paper entitled Characterization and Evaluation of the Mechanical Behavior of Endodontic grade nitinol wires. Endodontic files are used in root canal procedures. Manual files are made of steel, which are more durable and affordable. However, due to their rigidity, they can damage the tooth wall. Nickel titanium alloys can be used in both manual or motorized files. They are more expensive and do less damage to the tooth wall. Unfortunately, these files are prone to fatigue failure without any visual warnings, which can occur at any time after the first use with a high probability of happening during a procedure. The main objective of this work is to study the fatigue life of nitinol alloys, starting with wires and in future work in endodontic files. To test the wires, rotary bending tests with a constant strain region were done. The rotary bending tests were done on a custom-made testing machine. With these 3 at-20 pins, the machine can create adjustable bending configurations. To achieve a constant curvature in the middle section, the position of the pins is calculated automatically using a modified Euler-Bernoulli model. A FEM was also used to obtain a more advanced modeling to improve the predicted Euler-Bernoulli strains for the pin displacement used in the tests. Before doing the rotary bending test, a more traditional axle test was done. The objective was to categorize the material properties of nitinol alloys used in the wires. On the left plot, we can see the traditional superelastic behavior and the mechanically induced phase transition. On the right one, an uniaxial fatigue test was done in an elastic region showing the expected stresses. The properties obtained are used in both analytical and FEM models. Moving to rotary tests, on the left plot we can see the rotary fatigue life of several nitinol alloys, with its expected decrease of life with an increased surface strain. On the right we can see the plot for 2 alloys with the finite element modified strains. The fracture surfaces of the specimen were also analyzed under a SEM, where we can see the fatigue fracture propagation across the surfaces.